by the way that the quadratic systems work, there's 0 to 4 possible solutions. So if we take into consideration like a circle and a parabola, okay, we could have up to four solutions. Okay, we could have a circle and a parabola with 2 solutions. Okay, we can have, 3 solutions. You can have like a hyperbola where the vertex just touches here. Okay, you can have a situation with just one solution. Okay, where we have maybe like a circle with a hyperbola just tangent and the other vertex out here. Okay, so there's lots of different possibilities, but we could have no solutions, one solution, anything up to from 0 to 4 solutions. So what about this one here? What does this one look like? This is a circle and a hyperbola. So what we could probably get a sense of the types of solutions here if we take a look at what maybe the graph looks like. So I basically have a circle with radius 6. I've got a hyperbola trans x with a point there. The vertex is going to be +5, so it's going to be right there. So it looks like it's just going to be tangent and -5, so it's maybe somewhere around here. And trans x looks like it's going to go maybe something like that and something like that. Okay, so it looks like we have maybe 3 solutions here. Okay, now it just happens that it looks like it's tangent there. We just should confirm that algebraically. So if we're going to solve this algebraically, what are our possibilities? Well, we can solve it by substitution, or we can solve it by addition subtraction. So let's try for this one. We did substitution for the last ones, so maybe we'll do a subtraction, although we can easily do substitution. Okay, I'm going to add these 2 equations together, and these, the plus y squared and the minus y squared, will cancel out. So what do we get? We end up with x squared plus x minus 1 squared. The y's cancel out, so 36 plus 25 gives us 61. Okay, so then I can solve this quadratic equation. I have one variable, one equation. So I end up with x squared plus x squared minus 2x plus 1 equals 61. This is 2x squared minus 2x minus, I'm going to bring the 61 to this side, so it becomes minus 60. Okay, so I can try solving this quadratic. It looks like I can factor it. So what numbers multiply to 30 and have a difference of 1? Okay, it looks like it's going to be -6, +5. And we kind of knew that the 6 was going to be a solution because we can see that that's tangent at that point. So my solution is going to be x equals 6 and x equals -5. Now remember that the solutions come in ordered pairs, so we need an x and a y. So for x equals 6, okay, I'm going to plug back in to one of these equations. So let's maybe just plug it back into x squared plus y squared. So 6 squared plus y squared equals 36. Y squared equals 36 minus 36 is 0, so y equals 0. So there's one of my solutions at x is 6, y equals 0. Okay, so that's one solution. We've got another solution at x equals 5. Those should be these two here. So at x equals 5, when I plug it in, I'm going to get 5 minus 1 squared minus y squared. Actually, I'm plugging into equation 2. Maybe I should have plugged into equation 1, but okay, so when I plug it in like that, I end up with 16. Let's see here. Maybe I should plug it into the original one. So we're going to end up with 5 squared plus y squared equals 36. Okay, so we end up with y squared minus 25 from both sides, so I get 11 So y equals plus minus square root 11. Okay, so those are my coordinates for that other point. Okay, so if I look at the ordered pairs for these ones, that's going to be 5 square root 11. Okay, this coordinate here is going to be 5 and negative square root 11. So there's my system of equations. I've got my solution. So I solved for x first, and I plugged in x to get the y. So you can see how I could possibly generate 4 solutions, because this could have generated 2 solutions with that plus minus. And I generate 2 solutions here with the plus minus for each x. Okay, so there's 3 of my solutions for this quadratic. Okay, looking at this one here, well, if I do a substitution, it's going to be a pretty messy looking substitution if I substitute all of this into this y. So what's kind of nice about this one is that I actually have a substitution for x plus 2 squared. In fact, if I solve for the x plus 2 squared, okay, I'm going to end up with y plus 4 and then times 2. So if I want to do a substitution, I can actually substitute this linear term into there. So this is what I'm going to do for my substitution then. Okay, so this is equation 1. I've just rearranged equation 1 and I'm going to plug it into equation 2. So my equation 2 is going to look like this. 2y plus 4 over 4. Okay, because this is the same as this, which I'm going to replace with the x plus 2 all squared, minus y minus 3 squared over 9 equals 1. I'm going to multiply through by 36 to get rid of the denominator. So I end up with 18y plus 18 times 4 is 72. Okay, minus, I'm going to multiply through this by 36, so I'm going to end up with 4, and then y minus 3 squared. And that equals 36. Okay, watch your terms. There's lots of terms here, so you might want to use a few extra steps to do this. So when I'm going to multiply this out, I end up with 4y squared minus 6y plus 9 equals 36. Okay, watch your negatives here. So 18y plus 72 minus 4y squared plus 24y minus 36. Okay, and that's equal to 36. Okay, so I can see that this is all the constant terms are going to cancel out. So I'm going to end up with 4y squared. Okay, I'm going to group my y's together. So that's going to be plus 42y. Okay, and I'm going to end up with plus 72 minus 36 equals 0. Those are 0 pairs, cancels out. Factoring the 2 out. Okay, so I'm going to factor negative 2y. So y equals 0. And I get 2y minus 21. That's equal to 0. So I get y equals 0 is one solution. Y equals, looks like 10.5 or 21 over 2. Okay, so those are my 2 solutions for y. I want to plug back in to solve for my x. Okay, so just going to shrink this a little bit. So I'm going to start with my y equals 0 because that's going to be the easiest. So I'm going to plug my y equals 0 into here. So I end up with x. I'm going to maybe do this in a different color because this is my second stage. I have x plus 2 squared is equal to 2 times, I'm going to plug in my 0. Okay, so I'm going to start with that one. 0 plus 4. Okay, so I get x plus 2 is equal to plus minus the square root of 8. Okay, so x is equal to plus minus negative 2 plus minus square root 8. Okay, so that's one solution. So I'm going to have, maybe I should list out my pairs. Okay, so for negative 2 plus root 8, 0 is 1 point. Negative 2 minus root 8 and 0 is my other coordinate. Okay, so there's 2 points. I'm going to then solve for y equals 10.5. Okay, so I'm going to plug that in. X plus 2 squared is equal to 2 times 21 over 2 plus 4. So again, I'm plugging it back into equation 1, this equation 1 here. Okay, and then solving for x, I get x plus 2 squared. That's going to work out to be 10.5 plus 4 is 14.4. So it looks like that's going to be equal to 29. Okay, so 29, square root that. I get plus minus square root 29. So x is equal to negative 2 plus minus square root 29. Okay, so then those are my other solutions. I get negative 2 plus square root 29, comma, 10.5 or 21 over 2. There's 1 point. And I get negative 2 minus square root 29, and 21 over 2 is a y coordinate. Okay, so those are my 4 points. We should probably sketch this just to confirm our solution. Okay, this is a parabola. Okay, so I have my parabola. It's a parabola opening up. The vertex is down here. It's going to open up like this. This is a hyperbola. The center is at negative 2, positive 3, somewhere around here. And it looks like it's a trans x, so it's going to go like this and this, and we're going to have our points going out kind of like that. So there we have 4 solutions that's going to show up in this system. Okay, so it's going to be 4 solutions here. Let's go ahead and graph this just to confirm what we're seeing algebraically.